9 minutes long, so I'm very sorry if you having to read all that. I know you didn't, but this one will be much shorter, I promise. Alright, so what we have here is a very interesting situation. Tim Howard is not having a good morning due to his loss against Belgium recently in the World Cup. And upon his frustration, he spots a soccer ball on the street and kicks it up in the air with a velocity of 30 meters per second and at an angle of 30 degrees. What he doesn't know is that the Avengers are flying back from Brazil after watching that very same World Cup, and unknowingly, they have flown into the path of Tim Howard's soccer ball. And what we're going to do here is we're going to find the time it takes for the soccer ball to reach the Avenger ship, and then we're going to figure out the horizontal distance the ball travels, and then the vertical distance that the ball travels. And if you notice here, I have all my components listed on the right, and this is all the math that we did here to find it. So first off, what we do is we figure out the velocity in the x direction and in the y direction, which you can see here. We have the velocity in the y direction of 15 meters per second, and then the velocity in the x direction of 26 meters per second, which we're then going to use that to find the time. So we're going to do, we're going to take the equation, the velocity final equals velocity initial plus gravity times time. Well, we know that velocity final is going to be 0 since it's hitting the ship, it's stopping, so we know it doesn't have any more velocity. So we're going to do 0 equals 15 meters per second plus the 9.8 meters per second squared times t, and your time is going to equal 1.53 seconds. Next, we're going to find the horizontal distance in the x direction, which we're going to find by using the x equals vx times t, which is really just a distance equals rate times time. And what we're going to have here is we're going to have x equals 26 meters per second, which was the velocity in the x direction, then times the time, which we just found, which is 1.53 seconds. So we're going to get an x horizontal distance of 39.78 meters. So obviously the ship was pretty close to the ground. I know it wasn't too far away from him. Finally, we're going to find the y distance, the horizontal distance, how high the ball got kicked. And what we're going to find is that they were very close to the ground, almost unbelievably close to the ground. I don't think this would have worked in real life, but you know, this is physics, so it's fun to play around with these things. So we're going to have v final y squared equals v initial y squared plus 2 times the gravity times y final minus y initial. Well, we know that that y initial is 0, and we're so that's gonna go to 0. V initial in the y direction is going to be 0. I mean, v final in the y direction is going to be 0. So then we're going to have 0 equals v initial squared plus 2 times g y, and y is what we're trying to find. The y initial up here was 0 meters. I think I crossed through the y, but I didn't mean to. It carries down to that next line. So then we're going to have 15 meters per second squared times 2 times negative 9.8 meters per second squared times y. So you're going to get a y horizontal distance of 11.47 meters in the y direction. So it's going to be 11.47 meters tall. So there you can see the situation a little bit easier. So, all right, that's it. Thanks.